So now that you've had a bunch of practice evaluating logs, let's go ahead and look at the graph of a logarithm. So just like the other functions, there's a parent function and a parent graph. So the parent function is that y equals log base b of x. So when you graph these things, there's going to be some number in for the b. And we'll see what happens when it's in there. So the parent function, you have a vertical asymptote right at 0, and then the graph goes just like that with an x-intercept at 1. So why is it at 1? Well, if you plugged 1 in for x, that looks like what we just did on the previous example. It doesn't matter what the base is. If there's a 1 in there, that's going to make it equal to 0. So that's how we can get the x-intercept is at 1. Okay, so let's graph each of these, label the x-intercepts, don't worry about a y, and the vertical asymptote, then state the domain and the range. Okay, so again, these are just sketches. So when we change the base, it's not really going to change the shape of the curve. So whether it's base 2, base 9, base 4, it's going to have the same curve. If we were on graph paper and getting very specific, then yeah, it might have some different curvature as far as steepness is concerned and that stuff, but we're not worrying about that. You don't really worry about that, and when you do, like in your engineering classes, you're probably going to have some sort of a graphing aid. The point of the math class is just to give you, like, okay, do we have the right shape and the right intercept? And so you have a good idea as to what it should look like before you even have graphing software take over. All right, so log base 2 of x, well, that's pretty much your parent function. So vertical asymptote at 0, it's got the same curve, same x-intercept, because we didn't shift it to the left or to the right, so it's still going through 1, 0. Because again, it doesn't matter what the base is. It could be a 2, 3, 17. It's going to have an interceptor right at 1. Okay, now the domain, though, is going to be anything that was to the right of the vertical asymptote. So from 0 to infinity, anything positive. And the range, that is all reals, because it's going down forever and going up forever. Yeah, okay. Let's look at this one. Log base 2, so it's basically this curve, but now it's got an x plus 2. So what happened when there was something inside with the x? What did that do? Well, it shifted it either to the left or to the right. So think of like the radical graphs that we did, or the absolute value, or the parabolas. How did we figure out which direction it went? That's right, by whatever made it 0. So what makes the inside equal to 0? -2. So that means it's shifting over to the left by 2. So when you shift the 1, 2 spots to the left, that's going to be a -1. So your intercept is over there. So now your domain is from -2 to infinity, and the range, all reals. And there you go. Okay, part C. Now what makes the inside 0? That's a 9. So everything is getting slid over by 9. And again, don't make these to scale. So if you move the 1 over by 9 spots, it's now sitting on 10. So the domain 9 to infinity, and a range reals. Okay, now again, it doesn't matter what the base actually is. So whether it's a log base 2, log base 3, log base 10, or an ln, it's not going to change your strategy or your curves even. So the ln's are going to graph exactly the same as the logs because it's still a logarithm, just as a different base. Okay, so what makes this equal to 0? Positive 2. So everything got slid over 2 spots. So your intercept is now at 3. Domain 2 to infinity. Arrange all reals again. Okay, so now let's throw a negative in front of the graph. So what did that do to your graph before? That's right, it flipped it upside down. So it's gonna shoot it's gonna be pretty vertical going up, and then it'll start to flatten out as it goes off to the right but going down. And we have a shift over to the right by 1. And the curve is upside down, so it's going this direction. Right at 2. Range is all reals. Domain 1 to infinity. All right, so now this last one, it's got a negative in front of the function, so it's going to be upside down. But now the x is negative. So when the x is negative, it flips it over the y, and so like it starts to point in the opposite direction. So instead of going off to the right, now it's going to go off to the left. And we're shifting it over, so what makes this 0? That would be a positive 3. And your x-intercept is, if you put it over here on this on the right side, you're going to draw your graph like this, and you're going to go through your vertical asymptote. You can't ever do that. So for a log, if it's pointing off to the left, that means your intercept is on the left of that vertical asymptote. So that's going to be at, 2, 0. So your domain this time is from negative infinity up to 3, and the range is still all reals. Okay, so that should take care of graphing logarithms. So let's pause here, and we'll pick up the rest in the next video.